Hello class, my name is Josh Williams. Today we're going to discuss operating systems and firewalls. So let's get started. So the overall job of the operating system is to manage the hardware and to run programs, which in OS terms is also referred to as processes. In order to manage the hardware, the OS interfaces through a series of system calls to the hardware itself. Additionally, most OSs have device drivers that allow the OS to control a particular device. For example, when a USB stick is connected to your computer to upload a file, the driver of the OS reaches out to that device to receive the data that is stored on the USB stick. In return, you'll be able to access the file on the operating system. The OS is generally stored on the hard disk of the computer. The hard disk is a non-volatile memory, therefore the OS cannot be lost while the system is off. You can also put the OS on a boot disk, and you'll have to boot the OS every time that you start the system through this disk. But once the computer is started, the RAM copies the data from the hard disk or the boot disk to boot the OS. Additionally, the operating system provides a basic user interface for users to interact with the applications and files stored on the system. Operating systems typically provide a file system that allows the ability to read and write files without much concern of how they will be stored. This user interface can be in the form of a graphical user interface, which is what we're using for our Windows builds, or the command line interface as we are currently using on our Linux server builds in this class. The goal of the operating system is to allow for multiple processes to run at the same time. The problem with this is that one CPU core can only run the code of one process at a time, generally. So, how do we fix this? The solution is to have the CPU cores alternate each open process while running OS code. A portion of the OS called the scheduler runs after each process to decide which process, if any, should be ran next. The process of cycling CPU cores in this manner is typically referred to as preemptive multitasking, and that is the management of these processes. With all these components to an operating system, there are several ways that we can verify that it is secure. This verification is called OS hardening, operating system hardening. It is important to harden an operating system to ensure that there is a minimal chance of impact, especially for a customer-facing platform. The information security industry is trending toward availability for customers, and the only way to provide availability is to mitigate downtime. So OS hardening will definitely help to accomplish this, but this can be essentially done by following the lean as mean mentality, which is disposing of all software that is not essential for the functions of the operating system. Some hardening techniques include the following on the screen. So locking down unnecessary ports that are listening, adding secure passwords to all accounts, enabling syslog and auditing to provide evidence of system health, limit the number of users that have access to the system, encrypt all data with SSH keys or session keys, upgrading and updating is essential to patching the system for any vulnerabilities. Additionally, you can also change port numbers for specified protocols, but we are not going to be focusing on that because we are not going to be doing that in this class. But you could also use that technique for hardening your systems. While these steps are necessary to secure the operating system, there are other options for securing your system as a whole. One simple way of adding additional security to your server is by implementing a firewall. So firewalls are network security devices that allow or block traffic based on rules that are preset or assigned. Firewalls, by definition, lock unauthorized access while permitting outward communication. So the two that we're going to talk about today is the Linux firewall, IP tables, and the Windows firewall. So beginning with IP tables. It is a firewall system that is built for Linux. It is a command line firewall that uses policy chains to allow or block traffic. Of course, these chains are fully customizable, which makes this firewall very flexible. IP tables come pre-installed with any Linux distribution. It just needs to be updated or installed prior to use. You can also update or install with a simple apt-get command through the command line, because this is a command line interfaced firewall. So how does this work? When a connection attempt is made, IP tables looks at the rule sets that are defined and matches the attempt to one of these policies. If no policy is met, or the traffic type is set to be blocked by the firewall through a rule, the attempt is then dropped and connection will not happen. IP tables uses three different policy chains, which are input, forwarding, and output. The input chain is used to control the incoming connections. For example, an outside source wants to connect to your system. The IPs table will allow or deny the traffic based on the IP import. So based on the protocol that the outside source is coming in from, it will either block or allow the traffic based on the rules you have set. Additionally, the forward chain forwards traffic to another system or to your system if there's an applicable NATed address to your machine. So what is NAT? What does that mean? So network address translation is a common way to diversify the oversight of your system's IP. A NATed IP address is a forwarding address that you assign and implement within your environment. This chain is widely used to protect the IP of your system from external traffic trying to connect. So lastly, the output chain. The output chain is used for governing outbound connections. For example, if you are trying to ICMP or ping a device to verify that the device is receiving packets, the output chain will compare your attempt with the rule sets in the chain to allow or deny the ability to reach out to other systems. On the other hand, we have the Windows firewall. So the Windows firewall is a Microsoft Windows application that filters information coming to and from your system. This firewall has a GUI or graphical user interface that also comes pre-installed on the Windows OS. From the Windows firewall interface, you can add or delete rules, turn the firewall off or on, and even update the notification settings to allow the firewall to notify you of any suspicious activity. This firewall can block public and private networks based on the criteria or program that you assign. And additionally, Windows firewalls can secure the Windows system by blocking all unsolicited attempts to connect to your computer. Additionally, like IP tables, and the Windows firewall can filter both incoming and outgoing traffic. So in conclusion, understanding operating systems and firewalls is very important in understanding how to secure your system. Operating systems have a lot of moving parts, and hardening the system can reduce the risk of a breach. Firewalls are an excellent addition to protect your system. However, it cannot be the only thing protecting your system. It can't protect from all malicious attacks. Rather, you should use firewalls in conjunction with an antivirus software to further protect your system. Just want to thank you guys for the time to watch this video, and please feel free to leave any additional feedback or hardening suggestions in the D2L section provided by Professor Green. Thank you.